let's go back to checking this out. Trigger, I just want to clear, I always clear the trigger. Waveform, start over, start over. I'm going to overlay everything. Let's do chip select, address, read write, data in, data out. Chip select is always on 0. Oops. That's why I put CS0. So when it's 0, it's selected. Now these RAM, the chip select it's a 3-bit chip select, and they're all tied low. So it's always enabled. But I wanted to put that on the file anyway, because sometimes it may not always be enabled, right? So we have our address, data in, data out, read write. So I'm going to hook this up. I'm going to clip it to a chip, clip it to one of the RAM. And I did look at all those 86s, and they were perfect. So I've got this all ready to go. I've got it all put the way that it needs to be. And we'll go ahead and put it on these RAM. Okay. And I just want to do a single shot. Here's your single shot. F0F. Okay, this looks weird to me. Am I not connected good? Let's try it again. Single shot. Alright. It's enabled. We are reading. The data input is 0. Write at that address 0, and then read from that address. So we're reading and it's 0, and we're writing a 0 and reading, and it's a 1 coming out. Let's look at a different one. That looks strange to me. It doesn't make sense to me. Let's try this one. Okay, it's kind of the same thing. Now here we have, let's look at this. What's going on here? Let's try to understand this better. Okay, we have the input 1 right here, and at address, let me get my pointer. At address 49, we read from 49, and it's obviously it's a 1. Then we write a 1 at 49, and then reread it, and it's a 1. We move to 89, we read, and it's reading at 89 as a 1. Then they write a 1 and read it, and it's a 1. 09, read 1, write a 1, and then write, okay. F1, there's a read here, and it goes 0. So obviously there's a 0 there, and then we write a 0 and read it. And see, this doesn't make sense to me. If it's F1 and we're reading and it's 0, that's fine. Then they write, and data in is a 0, so that should toggle that to, that should be a 0 when we read it there. Well, actually, hold up. No. We read, because there's a little bit of a delay. So we read from F1 and it's 0. And that's fine. I don't know what was there before. And now we have a write cycle, and we write in a 0. Then we have a read cycle, and it's 0. And then we have a new address, 71. So I guess you're writing now. Now we're writing a 0 into 71 and we're reading the 0. So I think it should, like, half of a cycle. Hmm. 71, we read. Now is this thing activated on a trigger? If we're reading, if that's a 1, when we enter that address, is it reading, or does it read right here at this trigger, at this edge? Is this edge activated is my question now. I'm kind of going to assume that it is edge activated because this looks like it follows this. It looks like it follows at the edges, right? So let's just disregard this. We have a write, let's just call it a write and a read cycle. So we have a write of 0 and then a read from that at 0. Now we're in this address and we write 0 and we read 0. Now we're in this address, we write 0 and we read 0. That's how I'm going to kind of look at this from here on out. Oops. Let's go back to this. Now let's do this. Okay? And with that in mind, let's take another look at this. We're in this address and we write a 0 and then we read 0. Right? It's better to zoom that out a little bit. We're in this address is CC. We write 0 and then read 0. Now we're in, after we read that 0, we're in this address space, right? And we write 0 and then we read and it's a 1. If we're, no, we write a 1. Write a 1, read a 1. Now we're in this, we write a 1, we read a 1. This one we write a 0, we read a 0. Why did this go high right here and follow that? Maybe it is, maybe it does. I think I'm going to disregard this read. I'm going to disregard the high read because it comes into this address space. We don't know what's in that address. That's a problem. That's a problem with doing this. But you can see if it's reading and writing. If it's reading what it's writing, because that's how these buffer RAM work, is it writes a 1 into that and then it immediately reads that 1 back. So it should, in that read-write cycle, it's actually a write-read cycle. It should match. So I don't really care what's going on right here. Here's a write of 1 and a read of 1, and then it goes into a read and it goes low. So F4 apparently has a 0 in it, and we don't know that. So, but it writes a 0 and reads a 0. And then here it's, I don't really care what it's doing right here. Only at the edge is what I care about. So here we're writing a 1 and we're reading a 1. Here we're writing a 1, reading a 1. Writing a 1, reading a 1. We're writing 1 the whole time here. So we're reading, it should be a 1. We're reading a 1, and then I don't care about what's going on here because I don't know what's in here. Writing a 1 and it's a 1. And this is 1 the whole time. I mean, it's writing a 1 and everything, so it's going to read a 1, right? Here we have 1, 1. Write a 0, read a 0, write a 0, read a 0, write a 0, read a 0. Yeah, that's the, I can see that's the Achilles heel of doing this way, is we do not know what's in these addresses before they get written to. This read section right here, this where this line is high, where it's when it enters this address space and it's reading, we don't know what's in there. The only real way to test these is to pull them and put them in the Inquisitor and let that do a test. This will tell us if it's reading out what it's writing into it, but we don't know what was in it to begin with. That's the problem. Here it's writing a 1, so it should stay 1 every, unless this is, see, this could be a 0. There could be a 0 in there and it's staying high. That's the problem. Here's a write of 1 and a read of 1 until it gets into this address space. It's a 0 until it writes a 1. It writes a 1 and then reads and it's 1. There's obviously a 0 in here and it writes a 1 and it's 1. Interesting. But we can at least tell, I can see that it's at least doing that. Now, I'm going to switch back to a different one. Okay. Just kind of give this one a look again. This is writing 0 the whole way here. So writing a 0, reading, and it's 0. Writing 0, read 0. See, obviously there's 1s stored in all of these. So it's doing that. Now, I don't know if there's supposed to be 0s written into there. This might supposed to be low the whole time, right? That's the problem. I just don't know what's supposed to be in here. Write 0, read, and it's 0. See, every time it goes to read, it's 0 until it writes, and when it writes, it goes high. Data out. Why is it doing that? That don't seem like it should do that. Okay, this one, when it goes to write the 0, this is going high, like it's tri-stating or something like that. It seems like that should stay low while it's writing that 0 into there. Why is that data out bit toggling right there? That doesn't really make sense. I'm going to look at another one, keeping that in mind, and see if another one is doing that same thing. Okay, this one, we're writing a 1. It's a 1. This one, it stays. It doesn't, if it writes a 1 in it, it's staying. This one is writing a 1. It's not toggling like the other one was. Writing 0. See, this one is toggling like that one was. It's writing a 0 and then reading. This one is toggling the same way. Reading. Writing a 0, reading. Wow. You know what? I'm going to just have to remove these and put them in the Inquisitor and test them, because this doesn't really, you can't really do this. So I'm going to go ahead and do that. To cut to the chase. I found the bad part. And I'll show you how I found the bad part. I removed the line RAM. They were all good. Socketed and put them back in the spot. I started going over everything. Now, when I removed this line RAM, all of the lines go away, okay, and it's just a solid yellow screen with the characters on the background. So I was like, okay, it's something to do with the line RAM. It's something to do with it. And they are right here. And this is the middle one. When I removed this one is when the lines would go away. And it was just a solid yellow screen with the sprites overlaid on it. If I removed the other two, the lines would remain. So I knew it was associated with this one. So it was either something connected after or before, and I started before because most likely, once it gets to, you know, the output, it's already, I mean, I suppose it could be something around here, but I figured it was something in feeding and inputting these RAMs. So I followed it back. I tested all these 00s. They were all fine. And I kind of followed these signals back a little bit, and you got a mux here, and then all of these signals kind of originate from these 194s, where all the picture data from these ROMs are coming from, are shifted through these 194s down here. There's a big block of them. 1, 2, 3, 4, 5, 6. You can see I got a red mark on this one. This is the bad chip. 12L. And I cannot read this stuff. This one. This one is bad. And its bits go to the mux and into the next shifter. Yeah. But I got to where I was analyzing everything. I was like, man, I gotta move on. We did some, you know what I am going to do though? Let's look at this in the analyzer and analyze how it is not working properly. See, I'll show you. Let me grab a 194. 194. Okay. And I'll set it over top of that. I gotta kind of bend the legs a little bit. Okay. And put it over here. Try to. There it is. So obviously the bits coming out of that are incorrect. Obviously. So, yeah, you remove it and you're back to yellow lines. So let's get the analyzer. Let's analyze this thing and look at it and see how it is not working. It would have done me well when I had my analyzer set up for analyzing 194s. I analyzed the 194s on here. If I would have just moved over and done all of these really quickly, I would have found it a lot quicker. But let's analyze this 194 and take a look at how it is not working correctly. Okay, here's a 194 shift register, and these are fun. The way that this works is it has multiple functions based on the inputs S0 and S1. So basically, the function when you see S0 and S1 as a 1-1, that's a load function. And if you see 1-0, that is shift from the left. If you see 0-1, that is shift from the right. And then you have a right in and a left in. This is a bidirectional shift register. It can shift left or right based on, like I said, the function of this. The way these are set up is they basically are only shifting from the left and loading. And there's also, if you see 0, 0, that's do nothing. So there's 4 functions. There's load, shift from the left, shift from the right, and do nothing. And I say shift from the left and from the right because it can be confusing, because a left shift doesn't mean they shift left. It means they shift from the left to the right. So I say shift from the left, shift from the right. Okay? Here you have a load, and it's actually loading 0, so that doesn't really do anything, doesn't show us anything. And I'm triggering on load right now. That's the best way to look at these, is to trigger a load. Now we have an input here of 1110, and at the rising edge, let's move this all the way over to the edge of this rising edge, because everything's done by the rising edge in these things. So here we're loading at this rising edge right here. I need my pointer. I need my pointer again. Okay. At this rising edge we are loading at the output 1110, and you see that right here. In the left input, the shift from the left input is 0. So, okay, this clock pulse, we shifted that in. Shift from the left is 0 the whole time, so we're going to be shifting with each pulse a 0 through. So we come over to the next rising edge, and that right here becomes 0111 right here with this clock, because we shifted in a 0 from the left. The next one, we're going to shift another 0 in from the left, and it's going to move these bits that way, so that it's going to become 0011, and you see that right there. Okay, and then that's where you see that. And we have at this rising edge, it's going to shift another 0 in, so it's going to become 0001, and you see that right here. And then it's going to shift again, and this one's going to exit, and you're going to have zeros, and that's what you have right there. Now we're just, every clock pulse you're shifting a 0 through, so it's just always 0, and that's what you see. So and you can look, and that way you're checking the load function, and that's how these are always set up to work. Load in a value and then shift, either left or right. Yeah. You just keep going until you find something. See? It's not exactly terribly active, is it? You know why it might not be terribly active is I think this is the next in line after the bad one. Here, let's look at this. Let's come back over this way, and you see here we've got some busyness here. Let's check this stuff out. Okay. Here we have a load pulse of, it loads 1111 in right here. At this rising edge we are at 11 on S1, S0, so that means it's loading. At this pulse we load 1111, and that drops down to the output. Okay. So, oops, darn it. Okay. Now with the next pulse, we are loading from the left, because it's 10 shift from the left, and the left input is 1, so it's for these 1, 2, 3, 4 clock pulses, we're not going to have a change at all. It's going to stay 1 1 1 1 down here because the input is 1. So for the 4 clock pulses, 1 2 3 4, it stays 1 down here. You see that? Now SL went to 0 for 1 2 3 4 clock pulses. That's going to move 4 zeros in. So we should get a 0 here, which we do, a 0 here, which we do, and another 0 here, which we do, 3. And then we're loading. And then this, see, this went to load. So we are loading 1 1 1 1 back in right here. So that is working just like it should. Now we loaded that. Now SL is 1 again, so we're going to have 2 clock pulses of it staying 1, and we do right there, and then that goes to 0, so we have 1 2 3 4, should have 5 clock pulses of 0. There's 1 2 3 4, and then it stays 0 because it's already 0 until we get to this load pulse. And now we're loading, but it loads 0, so it just stays 0. See there? And now we're just clocking zeros in. So this one is working properly. Now we're loading 1 1 1 1 back into the register. And for 1 2 3 pulses, we stay 1. So there's no change until this pulse where it goes 0, because that's low now. So 1 2 3 4 pulses of 0 should clear that right out, and you see it does. Clears it right out with zeros. And then we have another load right here of that 1 1 1 1 1 0 0. You see that gets loaded right there. And then we have 2 1s come in because this is high, 1 1. So this becomes 1 1 1 1 right there, you see, and then it starts shifting zeros. So that's how that works. Let's look at the bad one. Let's get this centered to zeros, and we'll look at the bad one and see how it is not working. Go ahead and move it onto it really quick. Okay, I'm on the bad one now, and let's give it a shot. See what we're doing. Okay, we have the output. Okay, we're shifting left, and oops, we're shifting left, and we should be shifting in zeros. And you see that that's a 1 on the right there for some reason. I don't know if you can see that, but there's a 1 on the end for whatever reason there. Now we're loading zeros, so it goes back to 0. Yeah, check this out. Here's a 1. We're loading zeros in for 1 2 3 4 clock pulses right there. That should be 0. That would clear that out. So do we have a, it's not stuck though, it's not a stuck bit. See, it's 0 here. It loaded 0, so it went to 0. Now we are shifting left. Right here we load 0 in, so okay. Alright, right here we've loaded 0. Now we're at this pulse, we are shifting a 0 in to the left, from the left, shifting in a 0 from the left, because it's 1 0, that means we're shifting from the left, and we have a 1 here again. See that? That 1 showed up right there. So even though it says shift from the left, whenever, I don't know what, it's just not working right. There's a 1 on shift right, and the 1 is showing up here when it's supposed to be shifting zeros from the left. And you have a 1 here for whatever reason. That's an error. that's what's wrong with that one. This thing ever load anything other than 0? I think I saw 10111. Let's try to trigger on a in of 0111. Okay, yeah. Now we load 0111 in. I like to come over to the edge. We've loaded 0111 into the counter right here, and it's set now to shift left. Shift in from the left is 0, so at this next pulse we should get 0011, and we do. At this pulse we get 0011. The next pulse we should get 0001, and we do 0001, and the next pulse we should get 0000, and we don't. It stays 0001 when we should be shifting a 0 in. So yeah, it that last bit, that least significant bit does not want to go to 0. That's the problem with this thing. Yeah, and that is why when you look at bits like this, think of them as active 0. It's kind of hard to explain, but 0 drives everything in these circuits. Everything is driven with zeros. So if you see, like, it kind of makes sense. You got the absence of color would be a 0, right? And you have these bars, these lines on there. So you have ones where they should be 0, and you have lines on the screen, right? Yeah. Kind of makes sense if you think of it that way. Where there should be no color, which is black, you have color, right? So anyway, yeah, that's how that is not working. So I'm going to go ahead and replace that 194, and this one will be good to go. Yeah, and for future reference, you should have known right off the get-go that this was Sprite related. And those 194s do shift the Sprite data. Wherever there's sprites, it's kind of like this. These lines follow the sprites. See that? Yeah, just something, you know. And the text overlaid is not a problem. It just seems like wherever there's sprite data, and it covers the whole screen too. And it's, you can see that the character stuff is kind of overlaid nicely. Yeah. Anyway, that's for future reference for myself and for anyone else who's runs across anything like this. If you see something kind of following sprites, I guess, or in the path of sprites, that's goofy, like that. Yeah, these are sprites. I don't think that the burger stuff is actually sprites. I think that the ag and the moving stuff, you know, because even though these do fall, I think that's just position of them, of the burger stuff. I don't know. Anyway, yeah, just pointing that out. Yeah. New chip. BurgerTime. Well, I think I will go through and replace some of these caps, because these caps look a little worn out. So I'll replace some of the caps. Put some new standoffs on it. This had some pretty cheesy standoffs, kind of. I don't know. One of them's broken, yeah. I'll put some new standoffs on it. And caps. Then we'll come back and play a game. Okay, sound section is all nicely recapped with high quality Nichicon caps. I'll put some new heat paste on this, put the heat sink back on. I replaced the caps on that one as well. And if you watched the Super Breakout repair, I did not record. I did replace the caps on that board as well. So that's part of this job. So those have been replaced as well. Remember, the Night Driver already had new caps. So this one's all done. I'm going to go ahead and put that heat sink back on. Put it together with some new standoffs. And it should be good to go. And here it is in all of its glory. All recapped. This is back on it with a nice amount of heat sink paste. Keep that cool. New 3/4 inch standoffs. And we will give it a go. I'm sure I'll be able to do this without making you too sick. And my battery's going to die, so I'll make this quick. Come on. Sorry. So sorry. Just a quick game because the battery's going to die. Tis going to die. Game over. Yeah, I just wanted to go ahead and get the game over because my battery is about to die. So I'm going to say thanks for watching. We got another one fixed here. That completes this job. 3 boards. And BurgerTime. Good to go. Thanks for watching, guys. And we'll see you on the next Classic Arcade Repair. Bye for now.